Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover chapter 9 of grade 6 and the name of the chapter is Symmetry. Student, in this chapter, we are going to cover different topics. Let us look at the different topics we are going to cover. So, we will see what is the meaning of symmetry, what is line of symmetry, what is rotational symmetry, what is angle of rotation and what is the order of rotation of a object. Yes, now students, first of all, let's start with the first topic, that is symmetry. What is the meaning of symmetry? So, symmetry means when a figure is divided into two equal halves such that the two halves are identical, then we can say that that object or that figure possesses symmetry, and the line dividing those two halves are called line of symmetry. So here we have some examples of objects, like we have a sunflower, we have a leaf, we have a tortoise and we have a car, and we can see that none of all from all of these, some of them can be divided into two equal halves and some cannot. Like here the leaves and sunflowers has been divided into two equal halves using this line of symmetry shown using dotted line, but here tortoise and car was not in two equal halves, so we can't say that they possesses symmetry. So for object to possess symmetry, it is quite a task that we have to divide them into two equal halves. Yes, so a figure that is not symmetrical is called asymmetrical figures. Yes, so for 3D objects, line of symmetry is basically for their pictures only, because for a real 3D object we have a plane of symmetry which we'll discuss in our later classes, but as of now we are just dealing with the picture of those 3D objects like car or tortoise or sunflower or leaves. Yes, because this symmetry of or line of symmetry works only for 2D objects. For symmetry of 3D objects, we have plane of symmetry instead of line of symmetry. Yes, now a line of symmetry is also called mirror line. This line of symmetry, that is the line from which the two figures has been divided into two equal halves, is also called mirror line. The line of symmetry divides the figure into two parts that matches exactly. Okay, so here is some activity that you can go through and understand how symmetry works. Here we have a paper which has been folded like this, and then a small cut has been given at the center, and when we'll open the paper or we have cut out like this, so we can see that the line where it was first the scissor was applied, so it will be the line of symmetry and the two part will look exactly same to each other. Next is line of symmetry for regular polygon. So we have understood what is symmetry and what is line of symmetry. Now for regular polygons, which are 2D figures, we have some special cases, like a polygon is said to be regular. So what is regular polygon? So a polygon having all sides equal, like square, or let's suppose we have, if pentagon, it is called regular pentagon, and for triangle it is equilateral triangle. So if all the sides of a polygon is equal, it is called regular polygon, and for triangle and quadrilateral we have special names like equilateral triangle or square for quadrilateral, but for other polygon we have only regular polygon as a name, like regular pentagon, regular hexagon. So regular polygons are symmetrical figures and also have lines of symmetry. Let us learn about the regular polygon and their line of symmetry. So basically in regular polygon, the line of symmetry is same as the number of sides they have. Like for equilateral triangle, their line of symmetry is 3. That is, the figures can be divided into two equal halves by 3 different method and by 3 different line of symmetry. One is passing from the first vertex, second is passing from this vertex, and third is passing from this vertex. So similarly, a square has 4 equal sides, so there will be 4 line of symmetry. Pentagon will have 5 lines of symmetry. Similarly, can you guess for the hexagon and octagon? Yes, for hexagon it is 6 and for octagon it is 8. Now next is reflection. So the symmetry that we are understanding is quite similar to reflection of figures. Let's suppose if we are standing in front of a mirror, what you will see? You will see that you will be have an exact copy in the mirror. Now the mirror is acting like a line of symmetry and the two objects are or two figures are exactly same to each other. So the concept of line symmetry is closely related to the mirror reflection. Take a mirror and place it along the line of symmetry of a figure. You will see that the image or reflection on one side of the figure is exactly the same as the given figure on the right side of line of symmetry, like this. Here, if we have a mirror and we place this figure like this, then we will have a quite similar reflection on the other side of mirror line. Now moving forward, here are some question you can try. Like, let's suppose if we want to complete the following figure such that the dotted line become the line of symmetry, just you can check how we can replicate the given figure on the one side of the line of symmetry. So next topic is rotational symmetry. So as of now we have studied reflection symmetry. There are various types of symmetry. For class 6 we have only rotational and reflection symmetry. So we have seen that in reflex symmetry the objects just have a replica of each other through the line of symmetry. In rotational symmetry, it talks about the symmetry when the figure is rotated about a center of rotation. Yes, so for example, let's suppose if we have an equilateral triangle, then if we want to rotate an equilateral triangle about 360 degree, then after 120 degree it will look exactly to its original figure that we have taken at the starting point. Yes, then at again if we rotate further at 240, it will again have the same figure, and after 360 it will again look like the same exact figure that we have taken at the starting point of our rotation. So it means in a complete rotation of 360 degree, the figure looks exactly to itself 3 times. So here the order rotation symmetry that we'll see will be taken as a 3. So basically a rotational symmetry discuss about a figure should look like exactly a copy of itself when rotated about 360 degree. Yes, so it can happen at 60 degree or 80 degree or 100 degree depending upon the figures that we have taken. Now, what is angle of rotation? So student, we have taken the example of an equilateral triangle. Now, what was the first angle at which the equilateral triangle was exactly the same of what it was at the starting? So it was 120 degree. So the first angle at which the figure looks exactly the same as we have taken at the starting point of rotation, so that angle is called the angle of rotation, because it was the first angle that we have taken. Yes, now student, sometimes some figure can be like that. If we rotate them about 360 degree, then it looks exactly same when it comes to its original position only. It means there is angle of rotation at 360 degree. So we will say that angle of rotation is 360 degree, and order of rotation symmetry that we'll see later is 1, but we will not say that the figure possesses a rotational symmetry, because to talk about the rotational symmetry, or to a figure to be have a rotational symmetry, the rotational symmetry, the order of rotational symmetry must be greater than 1, like 2, 3 or 4, because every figure will look like itself after a 360 degree rotation, because the position has been same after the rotation of 360 degree. Yes. Now moving to the order of rotational symmetry, which I have told you that how what is the number of times a figure looks exactly of its same that we have taken at starting while rotating it about 360 degree, and that number is called order of rotational symmetry. For example, if we rotate a rectangle, so it will look exactly to itself 2 times, one at 180 degree and other at 360 degree. So here the order of rotation symmetry is 2 and the angle of rotation is 180, because the first angle at which the rectangle was seen exactly of same we can say orientation or same shape is the 180 degree angle. Yes. Now we can see that at 90 degree it will look like this, at 180 it will look like this. So this was the first time when the figure was quite same and exactly same, I will say. Then at 360 degree it again have the same orientation and same figure. So there are 2 order of rotation symmetry for rectangles. Now student, moving to rotational symmetry of circle. So it is quite a special case of we can say rotational symmetry. So we know that for a circle, line of symmetry is also infinite. It means a circle can be divided into 2 equal halves through its diameter, and a circle have infinite diameters, because a circle has infinite points on it. Yes. So similarly, if we have a circle and if we rotate it at a slight angle also, then also it will look same as a circle, because it is quite a same distance. Every point is at the same distance from the center. So for a slight rotation also, the figure will look same exactly to what we have at the starting. So we can say that here the angle of rotation is infinite, because for any angle, the circle has a rotational symmetry, and the order of rotational symmetry is also infinite. Yes. So if we talk about angle of rotation, at any angle is the answer, and order of rotational symmetry is infinite, because we can't count the number of times it will look same. Yes. So if we rotate a circle at its center by any angle, it fit on itself. This means the circle has rotational symmetry around its center for the point through which a figure is rotated for the rotation symmetry is called center of rotation. Yes. So center for any angle of rotation, not limited to specific value. Consequently, a circle has infinite number of lines of symmetry through its diameter, and order of its rotational symmetry is infinite. Here let us also show rotational symmetry and reflection symmetry that we have talked earlier. So for example, letter M, so we can divide it using vertical line like this. So M, if you write M like this, and if you want to divide it into two equal halves, you can pass a line through this point and it will have a copy of figure on the both side of line of symmetry. So order of rotational symmetry 1, because M will look like exactly as M when it will be rotated through 360 degree only. Yes. So rotational symmetry is no, because it should be greater than 1 to have a rotational symmetry. Yes. Now there are some examples of figures having reflection and rotational symmetry. So there can be some figures which can possess both, and some figures can have only one type of symmetry, rotational or reflection symmetry. So you have to look upon the figures and have to identify how many lines of symmetry are there, what is the order of rotational symmetry, or which figure will have a rotational symmetry or not. So having an order of rotational symmetry greater than 1 will include figures to have rotational symmetry only. Okay, so students, all this from this chapter, I hope you have understood the concepts of symmetry, what is line of symmetry, what figures possesses lines of symmetry, and then rotational symmetry, order of rotation, angle of rotation, and I hope you have understood all this quite easily, and now you will able to solve these questions given in your textbook, and also try to observe in your surrounding how different figures have different symmetry. Yes, like trees, leaves, flowers, etc., butterflies. Yes, so you'll find that in nature we have a beautiful patterns of symmetry, like in our architecture building like Taj Mahal and all. So you can just look around yourself and you'll find symmetries everywhere. So I hope you have understood the topic, and we'll meet in the next session. Till then, keep practicing, keep learning.